Okay, so this is going to be our first chat about planning out the migration of moving Elasticsearch services off of Elastic Cloud and onto a self-managed Elasticsearch server. I created the Google Doc there and put agenda items deliberately at the bottom because I think we'll probably want to start off with just like exploring the problem space and the code and sharing knowledge as much as we can before answering some of the questions I had on there. But I think, Matt, you had some topics to start us off with yesterday with regards to you wanted to talk about how the indexing pipeline works, how it relates to Sidekick or the Go Elasticsearch indexer we use, or various other different things. How would you like to start this conversation off? Or what's the first?
Actually, yeah. Well, I think we can probably knock out at least at a high level, your agenda items real quick. The list of questions you already put on there.
Okay.
Yeah. So for initial cluster sizing, yes, as a first cut, unless there were some clear indications that we were significantly under or over capacity, which I haven't seen any indications of that yet. I think it makes sense to just begin with that as a swag, and make adjustments if we find a need. I don't expect it to be like I don't foresee any reason that we need to tinker with that in particular, since this is not primarily a cost-based. Sorry, it's not primarily a cost-driven exercise, and we're. It didn't look to me like we were necessarily massively under or over provisioned.
Yeah.
That said, I think as once we get a better familiarity with the cluster, with the cluster state, I do want to both look at some of the profiling data that we're already collecting, and we'll certainly want to talk about what additional profiling information, sorry, both profiling and standard metric collection we're going to want to add for our new cluster. So we obviously don't have fine-grained machine level machine resource measurements in our current setup, and we know that the nodes that Elastic Cloud runs are multi-tenant. So the JVMs are single tenant, but the nodes are not. Is what I've heard.
My understanding there were Docker images and some orchestrated multi-tenanted environment, but yeah.
So yes, so I'm sure that there will be. I'm sure that we'll get better insights into resource usage and whatnot. But just as an initial swag, I think it makes sense to to stick with roughly the sizing that we've currently got with Elastic Cloud.
Yeah, I think we can only really get indicative specifications about what kind of servers we're running on right now, and not precise. But based on the pricing, like I think there is a table somewhere that describes how many vCPUs you have, etc. So we'll probably have to check that and try to match that against whatever specific servers they have in GCP that we can request.
Yeah,
that sounds like a good starting point. Yeah.
Yeah, and I think that the cluster that we're at least I believe that the cluster that we're currently running in is in GCP. So we'll certainly be able to get similar instance sizing.
Yeah, they don't seem to use exactly the same names. I think last time I looked into this, there was some specifics around figuring out what exact named instance they were using, and then we weren't 100% sure how many CPUs they were meant to have based on the way it was described in the table. Plus, it doesn't specifically say whether they're running SSDs, but I think we determined they must be running SSDs.
Oh yeah, yeah, absolutely, yeah. I wouldn't consider putting a cluster like this on spinning disk. The vCPU count, we can take a swag at that. The memory sizing is probably the most one of the most important aspects, and we'll I'm pretty sure I've seen I can't remember where, but I'm pretty sure I've seen some indications of heaps. I think I've seen some heap sizing information from the cluster.
So yeah, they tell you the memory size. That's actually what you select in the Elastic Cloud UI. So we're running 64
that's
gigabytes
right.
memory instances, and then
Right.
all of the monitoring informs us that that's 32 gigabytes of heap. So
Great. It occurred to me after a few days ago that that this is, I think, probably the first JVM based service that that the SRE team here is going to take responsibility for. I've been working with JVM based services for many years, so that didn't occur to me as kind of a new thing, but I'm very comfortable with that, but I will want to.
that will come in handy. We'll need all the help
Yeah.
we can get in that area, because a lot of those low level details are the kinds of things that we're going to need to performance tune eventually and help answer some of our current performance problems as well.
Yes. Yeah, I'm really curious to see. My recollection. So I don't have any expertise with Elasticsearch. I think I mentioned that before. I have worked with it in the past. And was kind of a minor contributor to maintaining some Elasticsearch clusters about 3 or 4 years ago. And my recollection that from that, that's some of the foundational things like the indexes are composed from shards, and how many replicas you have of each shard is one of the factors in sizing and things like that. Those are obviously still important concepts, but I've been trying to go through some of the Elasticsearch documentation to kind of get myself up to speed on what's changed in the last several years, and I'm sure that you're going to have a lot of good that you're going to give me some aha moments as well as we walk through this. Anyway, yeah,
there's a good doc here, Elasticsearch from the bottom up. That's like one thing I read pretty early on.
Oh, cool.
About Elasticsearch. Helps kind of explain the concepts about segments and shards and how the index works. So probably worth a read.
I think let's see what else. Yeah, like as I recall, running self-managed Elasticsearch, I think Elasticsearch did a pretty good job in terms of like auto-tuning the JVM GC settings out of the box. So, but I definitely am interested in seeing, in getting as much info as we can out of the existing Elasticsearch cluster. I'm not sure if we have any visibility into things like the distribution of GC pause times and kind of the more nuanced details about how, like which of the several GC algorithms is actually being used in these JVMs, and this really kind of matters more for applications that need to be fairly responsive on a tens or hundreds of milliseconds timescale, and I kind of don't have a good sense yet of like our use cases. At least I don't have a good sense enough. I don't have a clear enough sense of how responsive our search results need to be.
Well,
sorry,
I would certainly say long-term target should be, my idealistic target would be 200 milliseconds, but we're actually a long way away from that. And I feel like one of the things, I can just start showing random things that I have access to. So hold on, that I can show you in terms of metrics, so they can guide this conversation a bit more clearly. We have this Rails controller dashboard here, and I don't know if you've seen this one, but if you go, this is one of the new ones we built, and it has Elasticsearch timing down here. So this is the amount of time spent on an Elasticsearch query for the search controller show endpoint, which is the one that our UI uses. And of course, there's an API as well, and there's an API service that you can look at the Rails controller dashboard too. Every request logs Elasticsearch duration. If you look at the logs, there's an Elasticsearch duration in there. That's the total time spent on Elasticsearch queries for the endpoint. Almost all endpoints are only really doing one Elasticsearch query, so therefore it's the time it takes to search what you looked for.
Makes sense. And
Now,
if I remember right, sometimes we were like in the, above that 1,000 milliseconds for some searches. Is that?
yeah, well, I mean,
Is
this is saying that our median is like 2.5 or something seconds. So
Oh gosh,
really
yeah, my
not.
monitor's a little small, so I'm squinting at that. I see
Yeah,
what you
I
mean
think
there.
I'm running actually a zoomed out thing. So yes, this is not good. And annoyingly, I was trying to figure out why this is today. We should have like, I don't know, this is all in Prometheus. This data gets pushed to Prometheus with every request, like our Redis duration and our other things. But for some reason, I couldn't get more than 7 days worth of data here, which I was not happy about because I feel like this has gotten worse in the last month and I'm not 100% sure why. I think this query is timing out and that we do have more data than this, but I'm not exactly sure if I'm right about that assumption.
Wow. Well, if it's, gosh, if it's okay, we should look. Yeah, we should definitely look into how that what's backing that metric. Then I would expect
Yeah.
a longer 7 days. 7 days kind of sounds like that's roughly the time scale that we have retention for logs
Kibana.
in. Yeah, exactly, for logging cluster.
Yeah, and so this is definitely pushed to Prometheus because I wrote those metrics and it's queried from Prometheus, but I don't actually have the ability to edit these to show you the exact query that's using. But we added this, well, yeah, I added this in an MR recently. So let me see if I can find that. Elasticsearch.
Would you link to that panel in the dashboard?
Yeah, it's called Rails controller, and I'll link to it now in the doc. It occurs to me I also ran like a kind of workshop thing with all the backend engineers on the team a few months ago that actually detailed all of our metrics and all of the places we have metrics. So slightly out of date. We've got a couple of new things since then. There's a Google Doc and with all of the links and then a recording of that. So I will add that here as well.
Yes,
recording
yeah, I think we might have seen that already, but I'd definitely rather see a link twice than 0 times.
Okay, cool. Yeah, I'll try to find that later. Yeah, so anyway, I end up with no data when I look at that dashboard for 30 days. I end up with no data, and yeah, I'm not 100% sure what I'm doing wrong there. I will get the merge request where we actually added that graph.
Okay. For that panel, I'm kind of curious. I think you'll have access to this as well. If you right-click the panel header and
sadly, I'm pretty sure I do not because SREs have told me to do this before. I think just click on it and view the query or something, but I don't think I can.
Yes. Yeah. So right-click there and see. Try explore.
Explore.
Yeah.
Oh, maybe I think this is new because last time I tried to do this, I couldn't do it.
Yeah.
Oh, no, I've been logged out.
Oh,
Why you do this to me? Why did that happen to me? That's a weird timing.
No. Yeah.
Yeah, we enabled Explore for devs, or I guess for anyone who has an account really recently.
Oh, okay. That explains why I was sure I couldn't do it, but no, I can. Excellent. All right, so explore, these are the queries, the bucket, the merge request was here where we added it. And yeah, I actually have this same query used on the Sidekick details one as well, because we also have Elasticsearch duration for all Sidekick jobs.
Oh, yes, that makes sense. So yeah, one of my, I should stop bouncing around, sorry. Let's, if you don't mind, maybe.
Do you want to jump and share screen? And
I was just going back to the document that you'd shared to kind of go in order. So I thought maybe what I really want to do is kind of talk through the control flow, but I thought probably it made sense to just walk through the high level points you'd already outlined before we dig into that.
Cool. So we've got cluster sizing done. Migration plan. I feel like this is,
Yeah.
we'll want to go in detail at some point into these different topics, but
Yes. Yes, agreed. So we'll yes, at a high level, that sounds perfectly fine. The fact that we can pause ingestion into that we can safely pause ingestion into the cluster just gives us an incredible flexibility in terms of reducing the complexity of this operation. I had thought, yeah, I had thought that we would need to feed data into both the old and new cluster concurrently so that we'd be able to toggle back and forth. But since we can just pause ingestion for up to a few hours, that's we get a stable state without having to duplicate the data streams.
Yeah, that's come in handy a lot. So I mean, kind of then going back to control flow, the way that pausing ingestion works is a lot of our indexing happens through our custom implemented buffered Redis queues that the data is getting stored into. So we're not only using Sidekick for updates. We're actually using queues that we push our data into, and then we have a cron worker that's actually picking up batches of the jobs from that queue. And so the way that we handle pausing is we just don't consume anything from that queue. When the cron worker runs, it just goes, oh, it's paused, so I have nothing to do now.
That makes sense. And the individual jobs in the queue are small, I assume. Like we're storing like ranges of commit IDs, not the actual contents of the not blobs themselves, for example.
Correct. Yeah, they're just IDs of things that need to be updated.
Right.
So to kind of go into some of the detail around the control flow, you asked the other day about the GitLab Elasticsearch indexer. It indexes blobs and it indexes wiki blobs and commits.
Yep.
So those are all things that are in a repository. Now, those are not the only thing we index. We index issues, merge requests, comments, projects themselves.
That's what I thought. I didn't see where that was happening. So
yeah,
I'm pretty comfortable with the GitLab Elasticsearch indexer. Cindy and I haven't had a chance to chat too much about this. Like we've been independently kind of coming up to speed. So Cindy, I don't want to just take over the whole conversation. Please jump in.
Well, I know that we also index like the database, but I'm not really sure if that's separate from the like Git data, or do you know how that works, Dylan? Please explain to us.
And does it all go through Sidekick, or is only portion of it going through Sidekick?
So yeah, there's two index. There's a few indexing pipelines, 3 at most. Okay, so let me try to break this down. Indexing pipeline. Fine. Okay. Repo updates, Sidekick, jobs with project ID, and wiki true false. So what that means to say is if somebody pushes to a repository in GitLab for the master branch only, we will say, okay, a push has happened to this project. This is the project's ID, and it's not a wiki update. So that becomes a Sidekick job on the Elastic commit indexer worker queue. Indexer worker queue. So that corresponds to the Elastic commit indexer worker. That actually shells out to GitLab Elasticsearch indexer binary written in Go. That is what you looked at. The reason we have an indexer written in Go is supposedly this improves the performance. All the indexer does is it gets given a project ID and it goes to Gitly and then says, okay, Gitly, give me all the updates since the last SHA was updated and now. And it can therefore, in theory, load data from Gitly, marshal it into Elasticsearch payloads, send it to Elasticsearch in concurrent requests faster than Ruby can. That's the reason theoretically that this is written in Go, but it's not actually a separate piece of architecture in Go. It's actually just a binary that we build and shell out to.
Yep, that's what it looked like. I assumed you did it in Go just because it was a convenient way to get the gRPC
But we have all of that.
for the
We have all of that
proto-buffers.
stuff in Ruby anyway.
guess, yeah.
So
Yeah, that's true.
in theory, my preference would be we didn't have this Go thing because it's an extra thing for us to build and maintain and then bundle into the thing. But anyway, whatever. This is how it works, and supposedly it's more performant. But the key thing to understand here is actually it's actually a Sidekick job. That
Yes.
every project update to a repo is a Sidekick job. There is
and you mentioned that it only runs for the default branch. Is that right?
Yep, only the default branch master, or yeah, well, it's the default branch technically. Configured in GitLab is what gets indexed.
Okay. It looked like it accepted optionally taking a from and to SHA, which made me think that you could potentially do it with any arbitrary branch or any arbitrary range of
no, the
commits,
from and to SHA is a legacy. We can't change the arguments to a Sidekick job, but those are ignored now. So those from and to SHA like are sent to that Sidekick worker, but they do not do anything.
Gotcha.
Then I wonder if it helps like showing code while explaining this stuff, or what do you think with regards to that? Okay.
Yeah.
Okay.
I think that would.
Okay, so let me just go. Okay. Elastic commit index. Okay, my thing too. You are seeing my terminal right now while Vim slowly loads like my index.
A Vim empty file. Yeah.
Yeah, I'm just loading the autocomplete. Okay. Elastic commit index worker. That here, this thing calls to a thing called GitLab Elastic Indexer.
Yep.
Which ultimately shells out to the binary, but you can see these two shards that are passed as arguments are deprecated and they're unused. Yeah, that eventually shells out to the binary in here, and yeah, really the only thing that matters is like we're either indexing the wiki for the project or we're indexing the repository itself for this. Now, the second part of the indexing pipeline is a thing called the processing bookkeeping service. My Vim is quite slow when I do that. Process bookkeeping service here. Now, very elaborately named, but this thing is responsible for keeping track of updates to anything that aren't repositories, so issues, comments, etc. Every time an update happens to an issue, or an issue is created or an issue is deleted, we call track with that issue. And this gets stored into a Redis sorted set, and that Redis sorted set contains just the ID of the thing that needs to be updated. Then we have a Elastic bulk worker, bulk cron worker, Elastic index, okay, initial. So this is for newly created projects, and then there is a worker for Elastic incremental, Elastic index incremental, Elastic index bulk cron worker. Indexing control worker. Oh no, this is the one for pausing things. Okay, there's another worker here that handles updates for a incremental indexing. We separate initial indexing for projects from incremental indexing of projects because if you import a large project, we don't want it to fill the queue with what will be hundreds of thousands of issues, etc. And we only process 10,000 documents per minute. Every minute we pop at most 10,000 documents from the queue.
Oh, okay.
So we send them to Elasticsearch.
Okay, so this is like a coordinator that gradually feeds work into the queue to avoid starving other processes that want to inject work into the queue.
Well, actually, no, it's not exactly that way. There's two queues. There's two queues and two consumers of queues. Okay. So the incremental queue is consumed by an Elastic index incremental bulk cron worker, but I don't know why I couldn't find it before. And then the queue that's consumed by like newly imported projects is consumed by this one here I'm showing you, but both of them actually call out to this Elastic process bookkeeping service. And the Elastic process bookkeeping service, it has an execute method on it. And that execute method will pop 10,000 jobs at most from Redis, and then it will send them one by one to another class, which eventually builds up a payload of at most 10 megabytes or 1 megabyte of a bulk request for Elasticsearch, and sends all the documents in one go to Elasticsearch up to at most a megabyte. So therefore, if you had 10,000 documents and those 10,000 documents were 5 megabytes worth of data, then it would end up being 5 bulk requests. This happens every minute. It consumes this queue.
Okay, and that sounds like it implicitly also implicitly defines a maximum documents per minute rate.
Yes, there is. At most, we will be able.
Project?
No, per all of GitLab. At most, we'll ever index into the index is at most 10,000 documents per minute. Now, if I go and show you our metrics on that, it's more than enough to keep up. So like, for example, if our average documents, per minute updated in GitLab was 15,000, then we would forever be falling behind based on the architecture we have, because it's a hard-coded limit of 10,000. But we can see from Sidekick overview that we do not fall behind, and that we usually see kind of the queue size getting to no more than like a few thousand. So we have a separate section here on this Sidekick queues page for global search. And these are our custom implemented queues, and therefore we had to implement custom monitoring for these queues. They're not monitored like normal Sidekick queues. So this is the queue length of incremental updates, which is the main thing that happens. Like every time you create an issue, every time you update an issue, etc., it'll get added to this queue. And really, this queue never really gets above a few thousand, and it gets consumed every single minute. 10,000 of them get consumed every minute. So that's the second part of indexing pipeline. The third part of indexing pipeline is what happens, then the third part is the delete projects, and they get sent to a project, an Elastic project delete worker, something like this, some name like this. And the reason we do that is because it's got a completely different process. It executes a delete by query on Elasticsearch. Delete by query on Elasticsearch. So that needs to be handled separately from every other kind of update, because otherwise, because when you delete a project, it deletes thousands of documents from Elasticsearch. So we need to make sure that rather than sending thousands of updates for individual documents, we just use the Elasticsearch delete by query API and say anything with the project ID of this, delete it.
That makes sense. So it's a single directive to Elasticsearch that gets handled on the back end.
Yeah, Elasticsearch basically turns that into queries and then bulk deletes, as far as I remember.
Okay, that's great. Okay, that makes good sense. One of the in terms of like how we build the new cluster, it looked to me like all of the data nodes were enabled for doing indexing as well as servicing search queries, and that's certainly the simplest setup. I was wondering if separating those two roles was going to be an important aspect for building out the new cluster. And my inclination is to say no, unless we have reason to believe, like for example, if we have certain use cases that are going to result in a large increase in the demand for indexing, or conversely, if we have reason to believe that there could be large spikes in the demand for search requests that could potentially inhibit our ability to continue to ingest data. If that's a scenario we need to cater to, then it might be beneficial to separate those two. And I think, Cindy, since you're on call, you may have actually witnessed something like this during your shift for the logging cluster. I think that there was something going on earlier today about having in the logging cluster having some super expensive queries running that starved our logging clusters JVMs for threads.
So we were kind of trying to figure out what was causing that, but it was really hard to do without having some sort of slow log enabled. So we went ahead and did that, and we're kind of scared because we thought it might overwhelm our cluster, but it does have some overhead. Dylan, Mikhail was actually mentioning that, enabling slow log was something that you were interested in. I don't know.
Yeah, we asked support a while ago if we could do that, and they said it's not possible. So I'm surprised to hear that you were able to do that for the logging cluster, because yeah, I was under the impression there was no way to use the slow log on Elastic Cloud, but maybe it's new. I don't know.
I'm not sure what the difference is there. Like,
Yeah,
between the index in Kibana, like I'm kind of familiar with that, but like, where do you find the index for, just Elastic that it's not in Kibana? And
yeah.
how is that
Well,
managed?
yeah, well, that's what I was thinking. Is like, so Elasticsearch has its own, it's its own servers and it has its own logs, and the logging cluster therefore has its own logs. It doesn't send those logs to itself, and apparently there is no way to get those logs forwarded to another Elasticsearch server to ingest. We have a thing called a monitoring cluster today. The monitoring cluster gets sent metrics about all of the other clusters we manage, but as far as I know, when we asked about this, there's no way to forward the logs from one of your Elasticsearch servers to the monitoring cluster, nor to any other logging cluster. So, even if you could enable slow log, there's no way to read it, is what the advice we got was. But I might be wrong about that. It might not be up to date, and maybe they've added something new. There's some way to read the logs. There is, if you go to the Elastic Cloud UI, there's a page you can view logs of the Elasticsearch cluster, but it's just a single text page with no search functionality in it at all, and it's completely unusable.
That's the only thing I've seen. I was going to mention it. It looked pretty unusable.
Maybe that's why. Yeah, we enabled it for Kibana, and it does show up in Kibana, but like I was like, I don't know how that would work without Kibana. So
Interesting. Yeah, I'm not exactly sure what's the go there. I'm not up to date, and I'd have to ask Mikkel about what happened there, because it could be useful for our cluster as well. But of course, it doesn't matter if we move to our own self-managed cluster, then we'll enable slow logs, and we'll have access to it in exactly whatever way we want to forward those logs to. As for your question about resource optimization in terms of having nodes that are just responsible for ingesting, etc., I don't have any thoughts about that, but only because we just have never had the fine-grained metrics to tell me one way or another that that's a good idea. But if we learn that it is, we should do it. But
okay. Yeah, and if you haven't seen practical problems with it, then then we can start with a simpler solution and adapt if once we have the better visibility. Yeah, like since it's acceptable to turn off ingestion for up to a couple of hours during a planned maintenance event like this, I'm guessing that there's no current, like in terms of like setting expectations, it kind of sounds like users already don't expect to have near real-time search result.
yeah, that's
Is that right?
my understanding, and we've actually got at least 2 minutes delay in our indexing pipeline, because the indexer only runs every minute, and then on top of that, we allow Elasticsearch a minute between refreshes. So therefore, you could expect the documents to be delayed by 2 minutes before you see them in search anyway.
Okay.
Yeah, given that, we thought, okay, well, yeah, 2 minutes. What's 2 minutes if if it's 2 minutes that they end up probably won't notice if it's an hour as well. But yeah.
Makes
Anyway,
sense.
that's the kind of philosophy for now.
Okay.
In practice, indexing always is going to have some latency, and so we never want to use it in use cases of the application that appear to be real time. For example, like if you create an issue, you should be able to go to the issues list page and see that issue straight away, because it actually takes you to the issues list page under some circumstances. And if the issue you just created didn't appear there, that would be terrible. So therefore, that page is served by Postgres only. And anything that needs to appear real time like that is served by Postgres.
Yeah, makes sense. let's see. I'm just thinking about. I'm sorry. I'm keep coming back to control flow. It sounds like Sidekick jobs are the exclusive means for ingesting data into Elasticsearch. Is that right?
Yep. The only thing that should write to Elasticsearch is Sidekick.
Okay.
Well, with the exception if you change settings from the admin page, it will potentially execute write request to the cluster. But that's admin settings. Like it'll be if you wanted to change the. Oh, it's only when you create a new index that page will actually make a direct request to Elasticsearch.
Gotcha. Okay. Okay, that makes sense. So for routine operations anyway, it's only Sidekick that's writing. Okay, yeah. That's good. That's fantastic. Would you make a note of the Ruby classes that were involved in the ingestion pipeline? Process bookkeeping service was one of them, and I didn't type fast enough to catch the other ones.
So the documents from the DB will come from the Elastic initial bulk cron worker, and then Elastic bulk cron worker. Let me just search for these things. The other one is called the Elastic index bulk cron worker.
Then there was the bookkeeping service. Is that?
Yeah, those are both invoked by these cron workers I'm talking about. So I was just going to go top level because then even though all the logic happens in the Elastic index worker. I think this is the name of it. For some reason, I can't find the class right now. Both of these will invoke the Elastic process bookkeeping service, and this one invokes a subclass of the process bookkeeping service class, some kind. You can see when you look at the code. But those, if you jump to these top level worker classes, then you'll see what they do. But they're both consuming this process bookkeeping service class, which is effectively consuming a Redis sorted set as its main data store for pushing and pulling.
That makes sense.
Then the name of this one should be Elastic Delete Project Worker. Name of it. Okay, that is the Elastic Delete Project Worker.
Is there like one for groups, or is there only?
There is no. When you delete a group, I believe we loop through all the groups and we trigger an Elastic delete project worker for each project in the group. There is no concept of indexing groups in Elasticsearch. Like we don't index groups at all. So the index, is everything's done at the project level. And in fact, everything's routed based on the routing sharded to the right shard based on the routing key of the project. To begin with, we're planning on moving that because it leads to imbalanced shards. The shard sizes for us range from like 30 to 80 gigabytes or something like that, because some projects are bigger than others. Okay, I think I've linked all of the named of the workers there that are responsible for this. Yeah, that's that one. Okay, and yeah, these ones, the ones that have cron in their name, are both run every minute, and so they're not consuming Sidekick queues. They're actually consuming the Redis sorted set. After they run, they go and pop 10,000 jobs from that Redis sorted set.
Okay, and that sorted set is stored in the persistent Redis cluster?
Yeah, that's right.
Okay. Oh, I guess since it's consumed by Sidekick jobs, it's in the Sidekick's persistent cluster. No. Okay.
No. Sidekick. There is 3 Redis clusters. There's the Sidekick cluster. There's the cache cluster, and then the persistent cluster. We opted to use a persistent cluster, one because it's written to from the web application, but then again, so a Sidekick job, so it's sort of irrelevant. But I think the other aspect was that like it just it made sense for the Sidekick cluster to be purely Sidekick workloads using Sidekick's actual mechanisms rather than kind of muddying the waters. We implemented our own custom queuing mechanism. It seemed easier. Or maybe the reason was actually just to do with like the amount of available resources we had on that persistent state cluster was better for this. I can't remember the specifics. I don't know. In my head, it seems neater that we don't, confuse what that Sidekick Redis cluster does. Like it's only doing Sidekick's work, Sidekick queues, etc.
Okay, yeah, that's either way is fine. That both of those two clusters are configured with disk persistence. That they're not ephemeral. So from a data durability perspective, they're equivalent, which is the aspect I was most interested in.
Yeah,
of course, it's useful to know where it is regardless. Yeah, that's fantastic. Trying to think what else would be useful to cover at this point. I have this has given me enough information to go do some more homework, which is what I'd ultimately hoped for out of this session.
Okay. All right. Well, yeah, that's good then. Have you both kind of like seen how search works in the application? Like one thing that's worth noting is, okay, well, we have a performance bar up here, so you can see if a page actually used Elasticsearch, and you can see the query that it used. But in general, one of the things that people find quite confusing is that it is not used when you go to this issue list. It is, if you search something in here, this is using Postgres, and it's why it times out most of the time.
Okay.
Okay. It's only when you use the search bar up here that we're querying Elasticsearch. So.
Okay. Yes, I wanted to see the UI stuff. Cindy, I think, is more familiar with it than I am. But I know that there's a difference between something called, or something perhaps that used to be called basic search versus advanced search syntax.
Oh yeah. Yeah. So really, yeah. I mean, that's the topic is quite, yeah, like just confusing more than anything else. But if you ever perform a search and it says advanced search is enabled up here, that's how you know it's using Elasticsearch. And if you click on that link, it's going to tell you about the different syntax you could use. Like you can use hello or world, which will return you documents that have the word hello in it or the word world in it. And this is what we say is advanced search syntax, but it actually behind the scenes is just backed by Elasticsearch simple query string syntax.
This is like using like syntax, I guess.
Yeah, I believe that this is their own thing. I don't know if it's actually specifically using their Lucene query parser, but anyway, it's got a subset of different things that you can do in terms of operators, etc. And that, yeah, and then the search. Okay, then basic search. Well, it happens that some projects that are non-paid projects on GitLab, so anything that is not a paid project on GitLab doesn't have Elasticsearch enabled, advanced search enabled, which means we're not indexing it in Elasticsearch, and therefore we can't search for the documents in Elasticsearch. So, so if I go to a project, a personal project, it's not indexed in Elasticsearch. So let's search world on that personal project. I don't get this indicator up here saying advanced search is enabled, which means I'm using basic search, which means all of these things here are actually Postgres queries. So you can actually.
Oh, okay. So the user doesn't have to know which type of query to run. It's implied based. How do we infer whether it's indexed or not?
There's a table called the Elasticsearch index namespaces table in Postgres.
Oh, okay. I've seen that. Okay, that makes sense. And we just populate it. We populate it, I guess, when a new project is created.
When a project has a subscription created.
Okay. Makes sense.
It turns out that subscriptions data tables is like quite inconsistent, and the idea of like expiring subscriptions, etc., is not actually very well defined in GitLab. So I think like there's probably plenty of projects that are in there that actually no longer have valid subscriptions anymore. But based on the conversations I've had, yeah. So that table gets populated. That's as soon as that's populated, it triggers behind the scenes another worker. Oh no, that would be the Elastic initial index. Yeah. Another case for why a project's creation is going through a separate queue, because if you buy a subscription, you'll then have tens of thousands of issues and such that all need to be backfilled. So they go to a separate queue for that backfilling.
So I know we're recording here, so don't say any more than you're comfortable with for whatever audience is going to get a copy of this recording. But I'm curious what happened, like what the, just as background information, when a project is marked, like suppose a project switches from being public to private or vice versa, that the point at which that transition happens.
We don't allow public projects to be indexed for free,
Okay.
if that's what you mean. Yeah, that's one of the.
I guess I was more thinking of like for
permissions.
Yes.
Yes.
Exactly.
Okay. Yeah. So security aspect of this has been quite complicated. So basically, every query, which is quite annoying, has to replicate all of GitLab's permissions. So if I do a search here for hello world, you will see an incredibly complicated Elasticsearch query, which it lists all the project IDs for which I'm a developer, and it lists projects for which I'm a maintainer for which I'm a guest, with like separate different sections of this query.
Yes.
And like, if I'm a guest in a project, or if it's a public project, I can see issues, but I can't see confidential issues, and they're all kind of mirrored in here. Now, there is a latency when you update the actual permissions over in Elasticsearch. So there, in theory, is this kind of concept of a leak that could happen with the latency. Yes. In order to avoid that, we actually redact search results as they're presented in this UI. So we use the Postgres database to go and double check the permissions of the results that are served back from GitLab to redact any results that you actually don't have access to. If for whatever reason Elasticsearch was out of sync, or if we actually have a development bug, which we've had plenty in the past, for which HackerOne reporters got lots of money because it's complicated reproducing the exact permissions in Elasticsearch that were in the code.
Yes, absolutely. So that makes that's kind of what I was hoping, was that we either that we delegated it to the existing Rails code, or use that as kind of a post-processing filter after running the Elasticsearch query. And it sounds like we do the latter.
Yeah, and there's no way for us to really avoid. There's no way for us to only use the Postgres database or the local GitLab application for permissions, because we're searching a database of millions of documents, and some of those documents are public and some of them are private based on your actual permissions. So.
Yeah, that makes good sense. Okay. Awesome. Okay, thanks. That's really useful background info.
Okay. Cool. So, are there any other topics that you're wondering about that will be relevant for figuring out how to proceed on this?
We didn't talk about the migration plan, did we?
Not yet, really. No.
Yeah.
We can save that one for a follow-up one as we think about more different things. I mean, in my head, like, the actual migration is incredibly straightforward. The parts that are tricky are really like, figuring out what a good dry run looks like, what a good backup plan looks like, and possible disaster recoveries, and whether we test those disaster recoveries ahead of time, etc. Rollback points.
Sure. Yeah. Okay. So let's talk about just at a high level. So whether so for the dry run scenario, this is pause at a high level. This is pause ingestion at a known point in time. Make a snapshot. Export that snapshot from Elastic Cloud, import it into the new cluster. And at that point, we should have identical data sets on both the old and the new cluster, and run any validation routines we choose to validate the contents. Perhaps something as primitive as document count, probably something more sophisticated than that. And at that point, if it was a non-dry run, the actual cutover would be updating the I think in the admin settings area for GitLab.com, there's a URL that we need to update. And it could potentially be as simple as that.
Well, we got to unpause at some point, but yeah, not in the dry run.
After, yeah, exactly. From a testing perspective, So that gets us an Elasticsearch cluster running on the new platform that's got identical data content, and is not referenced by any running GitLab instance. So we could potentially stand up a new GitLab instance to point at that cluster and interact with it. In a read-only capacity, we could potentially run some sidekick jobs in a writing capacity to make sure that they can interact properly with it. Just in the pre-cutover testing scenario, not for the actual live cutover.
Yeah. So if we wanted to, so we would have to have a separate GitLab instance. It kind of has to have the same data because it doesn't.
Yes.
It doesn't totally make sense to have a separate GitLab instance without the same Postgres database, I guess. But yeah, if we had a separate GitLab instance with the same Postgres database, you could, in theory, update things and see that they made it all the way through to that Elasticsearch cluster. Kind of wonder if that validation beyond doing the whole thing on staging, how important that is. I don't know, but in terms of what risks we want to mitigate here, I'm pretty.
Yeah. I kind of feel like staging is sufficient for that.
I think, assuming we're
like
pretty confident that any disaster, like any data that ends up getting indexed or failed or whatever to the new cluster, like it can be recovered in some way, gets indexed to the new cluster, but we still want to roll back. As long as we can recover any of these scenarios, which I believe we can, and we think should double check that, but then I feel like we can be a little bit, less concerned about exactly how many ways we need to test this before we cut it over.
Yeah, I agree. I think that we should write out a concrete procedure for the specific settings to change and the specific steps to to pause ingestion and whatnot. And we don't obviously right now have to get into the details of that, but at a high level, I'm pretty comfortable with that as a sketch. How about you, Cindy?
I have a question, Dylan. You mentioned when we paused ingestion, like there might be some sidekick workers that kind of run through and index some data, and then you mentioned like maybe rerunning those sidekick workers once we move over to the new cluster. Is that
so? If we pause ingestion, there should be no updates that are processed at all and sent to Elasticsearch. What happens is, depends on the three different branches of ingestion that I described below, but the ones that are sidekick workers, like for example, the repository stuff, what they do is every time they get a project ID and they go, okay, I know I'm meant to index this project, but instead of processing the sidekick job now, I'm going to push it to a separate queue in Redis that I'm going to pick from later. So every sidekick worker is just actually taking work and pushing it to the side in Redis to remind themselves to do it later when we unpause. The replaying jobs that we might have to do in a disaster scenario based on logging would be if we unpaused indexing and all of a sudden started processing stuff to this new cluster, but then something went wrong. Like let's say this new cluster was just dropping work and it was throwing it away for whatever reason, and we just lost all of these updates. At that point in time, because we'd unpaused, we've lost a bunch of data. We would need to go through the logs and find in that period of time when we unpaused, what were all the jobs that were processed, what were all their IDs, we'd re-push them back through the indexing pipeline.
Oh, okay, that makes sense.
And that's the procedure that we should also document in test in detail, and we can do that in staging as well.
Yeah, that's exactly something we should have ideally had run books or something for a while now.
Apart from the actual migration itself, which we just kind of sketched at a high level, there's obviously the topology and setup of the new cluster for each environment, and the presumably meaningful changes that we'll need to make to our monitoring and profiling of those clusters. And I think that's a significant enough chunk of work that we'll want to talk about that in some dedicated sessions. I don't think I have quite enough information at this point about the current monitoring setup to draw meaningful conclusions about which pieces of that we're going to keep versus pitch. Like yesterday, I found out that the use of the monitoring Elasticsearch cluster is kind of a hacky workaround for the fact that we don't have host level details accessible from the Elastic Cloud as a service provider. And that won't be the case, obviously, when we're running our own.
Yeah, so I would be curious about whether or not like we really want to go down the road of reproducing everything that the Elastic monitoring cluster does in Grafana before we cut over, because we use the monitoring. I use the monitoring cluster a lot, and it's not perfect, but it's got a lot of data in it that it would take some time for us to get all of this monitoring data into dashboards in Grafana. So
that's part of what I want to explore is what's currently consuming, what's currently making use of the monitoring database, and so we can make an informed decision about the relative trade-offs of either replacing it but with Prometheus-based metrics and profiling data independent from the monitoring cluster versus configuring our new cluster to feed data into this monitoring cluster, or some third option that I haven't thought of.
Yeah, well, a third option would be another monitoring cluster that isn't the Elastic Cloud hosted one that we push monitoring data to. That would probably only make sense under the assumption that there was some difficulty pushing data from our self-managed Elasticsearch to the monitoring cluster that's run on Elastic Cloud.
So since our goal is to move away from hosting any of our clusters in Elastic, if we do decide to push our logging data to the existing monitoring cluster, then we'll definitely have follow-up work to kind of remove that coupling. Which, again,
and that follow-up might just be like turn it off because we actually have better monitoring in Grafana with all backed by Prometheus at that point in time. And if that happens, that's fine. But yeah, I just think there's quite a lot in here, so it would actually be quite a large project to do that. In practice, what I want to focus our energy on with Grafana would be adding new metrics that aren't available in this monitoring cluster. So I have even more data to look at when we want to debug certain things. And then eventually, we may replace this, but initially, I'd rather keep this and enrich what we have here with more stuff in Grafana and Prometheus.
So that's fantastic feedback. It's exactly the opposite of early feedback I got earlier from one of the SRE team members. So I don't have an opinion about it personally. I think it kind of depends on the level of effort involved. And the usage pattern. So what I'd really love is for you to, not necessarily right now, but I'd love for you to kind of walk through what you find valuable in your usage patterns, for example, of exploring the data that's currently available in the monitoring DB.
Yeah, that's fine. I think Mikkel will have a lot of good knowledge about this exact topic that definitely you should talk to him about his opinions about whether or not we need a monitoring cluster. The one thing I can say for now though is index-based metrics is something that is not in our Prometheus data to my knowledge, and understanding all of the details about what's going on inside Elastic at the index per index level. So the rate of indexing per index, the rate of searches per index, the performance of those things. We're going to be moving away from using a single index in Elasticsearch to using more indexes. All of that will start to become relevant.
I was going to ask about that. Yeah, it looked like am I right in guessing that currently it kind of looked like our existing search cluster only had one index for all projects. Is that true?
Yeah, and what it'll end up being soon enough is one index per type. We're moving issues into their own index soon. And we could, shard based on the specific project, but it's not necessarily a great idea because global search, where you're searching across all projects, still needs to be performant, and group-based searches will probably end up searching projects across 100 different indices anyway, so you may as well search them all. So we decided on moving per type into separate indexes. And I would say within about a month or two, issues will be a new index. But right now, there are actually two indexes. There's the migrations index and the actual data index. The migrations index is keeping track of essentially something similar to Rails migrations we've implemented custom for Elasticsearch, where we kind of on upgrades behind the scenes start moving data around for you.
That's all fantastic info and news to me. Thanks.
The migrations thing is all quite new, and that's because we're in the process of moving issues to a new index, and it's composed of several migrations in order for us to get to that point.
Got it. Makes sense. Awesome.
I can add
Wow,
links
this
to
is
that as well.
fantastic info.
All right. All right. So yes, so that's like a follow-up. Maybe you can think of and discuss with Mikkel as well at some point if you want to about whether or not we actually want to have a monitoring cluster. If we get rid of it, I'm ultimately not going to be too disappointed. I trust we'll probably have good metrics elsewhere, and we can figure this stuff out as we go. But yeah.
Just to be super clear, I'm totally open about how we approach this. We need to have access to we need to have good observability into the cluster, and I want to make it so that I want to make sure that that's as user friendly and enriching as possible.
Yep, great. That's what I
want. Which means
want.
talking to the people that are using the data, which means you and Mikkel and Igor and probably a handful of other folks.
Yep. I'm just going to add one more note to the doc here, which is not necessarily our indexing pipeline, but another thing that writes to Elasticsearch is our migrations use the Elastic migration worker, which I added to the doc there too. So that's something else that will write to Elasticsearch. It technically cannot be paused yet. The feature we have for pausing indexing doesn't impact this. So if this happened to be doing something while we paused indexing, then we would actually still see some possible write operations if the migration running is actually performing a write operation. Luckily, we have so few migrations happening and that we have such good knowledge of when they're going to be running that it's unlikely to accidentally cause us problems unless we're not paying any attention at all and to that. But worth knowing about. Okay, that's, yeah. I will, the other thing is I'll just leave a link to the performance monitoring thing I ran with the team at some point, and there will be links in there to all of the different places you can see performance metrics about Elasticsearch, and yeah. Okay, that is, yeah, good start. Should we schedule one more meeting next week? I can throw in the calendar, or what do people want? 2 meetings next week?
We could do 2. We
Okay.
can always cancel one if we don't need it, but
yeah,
it's nice
okay,
to have that
great.
option.
I added you both to the global search channel, so if you have questions in the meantime and you ask them in there, me, Dimitri, or Terry, or other people on the team should certainly be able to help answer those as well.
Awesome. Thank you very much.
Yeah, thanks.
No worries. I will send some calendar invites after this. Have a good afternoon then,
Awesome.
everyone.
Cool.
Thank you.
All right. See you next